Hello everyone, I am Dr. Abha Kumari. Today our topic of discussion is differential equation of first order but not of the first degree. Okay. Earlier in the previous lecture we have seen how can we solve the question of the form the case 2a, this is solvable for y. And today we will see the type 2b solvable for x. When the given differential equation can be put in the form x equal to x equal to fxyp, then it is called solvable for x. Okay. Earlier what we have seen that when the equation is of the form y equal to fxp xp, then we say that the given question is or given differential equation is solvable for y. But here today we will see how can we solve when the case is solvable for x. Okay. So let us see some problem. The today's question is solve x equals to y minus p square. So let's see the solution part. Given x equals to y minus p square, let it put it equation number 1. The given differential equation 1 is of the form x equals to y f y p. That is a function of y and the function of p is here in the right hand side. So we can say that this is the question of case 2. Okay, that is b solvable for x. So it is solvable for x and hence we differentiate 1 with respect to y. Earlier when we have the solvable for y, we differentiate with respect to x. But whenever we have a question of the form solvable for x, we will differentiate it with respect to y. So now we get after differentiation dx by dy equals to, here y 1 minus p square, while differentiating we get 2p dp by dy. Okay, this. Now this implies, now what dy by dx is p, so we will write dx by dy equal to 1 by p. So 1 by p equal to 1 minus 2p dp by dy. And this implies 1 minus 1 by p equals to 2p dp by dy. And this implies on simplification we have 1 by p and 1 by p both here in the left hand side and here in the right hand side. Okay, so what we get here is 1 minus 1 by p. So while taking the LCM, we have here is p minus 1. Okay, so here is p minus 1. So while taking the LCM, p minus 1 divided by p, and here is we have 2p in the right hand side, we take it in the left side, so we get 2p square in the denominator. So we are left with this term as p minus 1 divided by 2p square equal to dp by dy, and this implies dy equal to 2p square divided by p minus 1 and then dp. Fine. So this implies dy equals to 2 times, we can write that p square as p square plus p minus p while taking the 2 outside. Why this? Because we have a p minus 1 in the denominator, and to find its integration we have to just simplify it. So either you use partial fraction, but here I am using the term simplification, and we write like this: p square plus p minus p. Okay. So let's see the second part. So here we have this implied dy equals to 2. Now we just bifurcate this term in the two terms as p square minus p is taken the one bracket. So we have p minus 1 divided by p minus 1. Okay. And thereafter we have p divided by p minus 1. So this one we have just simplified the bracket into dp. So we have here as dy equals to 2 times, here p minus 1 getting cancelled. So we are living with the p plus. Now p divided by p minus 1, but we are not getting the integration of p by p minus 1. So again we are simplifying this term while adding minus 1 and subtracting minus 1. Sorry, adding 1 and subtracting 1. Okay. So we will write like this: p minus 1 plus 1 divided by p minus 1, and then we have dp. Now this is equals to 2 times p plus, now p minus 1 divided by p minus 1, we have 1, then plus 1 divided by p minus 1. So what we have done, we have just this into two terms, like p minus 1 divided by p minus 1, 1, and then plus sign, then 1 divided by p minus 1, so into dp. That means we get the term of the in three parts, like p plus 1 by p minus 1, and 2 is outside the bracket, and then dp. Now integrating both sides, we have here is left hand side we get the y, while in the right hand side we have 2 times bracket p square divided by 2 plus p plus log p minus 1 and some constant say k. This implies y equal to p square plus 2p plus 2 log p minus 1 plus 2k. Put it equation number 2. So eliminating p from 1 and 2, we get the required solution. Okay. So if we can eliminate the p from equation number 2, then we can just put this value in equation number 1, and thereafter we get the required solution. But since elimination of p is not possible in equation number 2, that's why we'll write like eliminating p from 1 and 2, we get the required solution. Let us see one more problem from this type. So question is, solve y square log y equal to xyp plus p square. Okay, here it is solved. Solve y square log y equal to xyp plus of p square. So let us see the solution part. Now given equation is y square log y equal to xyp plus p square. Since in the given question it is not clear that it is solvable for x or solvable for y, or it is a type 1, that is fraction of p. We can, if we can get the a fraction factor of p, then we can say that it is of type 1. But since the factors cannot be found from this equation number 1, so we can go for the type 2, that is solvable for y or solvable for x. But here what we have seen is that here only x is one time, rest of the p or y whatever given is more than one time. So if we have to place for the solver for x or solver for y, so we just search for the single term. So here x is seen only one time, so we can put it in the form of solver for x. Okay, so while putting in the solver for x, we have here is x yp equal to y square log y minus of p square, and this imply x equal to y by p log y. We have put it the yp in the left and right hand side, so we put this value in the denominator of this whole this term. So while putting this term, y and y getting cancelled, so we are leaving with log y log y divided by p from the first factor, and minus p square divided by yp, then p and p getting cancelled from the second one, and we are living with a p by 1. Okay, so here we have the term like x equals to y by p log y minus p by y, and we put this as equation number 2. Okay, so what we see here in this question is x is taken the left hand side, while all the functions of y or p is in the right hand side. So we will put this in the form of x equal to here x equal to what? Function of y and p. Okay, so we can say that this is a solver for x. Fine. Now equation 2 is of the form x equals to fyp, so it is a case of solver for x. Now differentiating 2 with respect to y, we get dx divided by dy equals to 1 minus 1 by p square dp by dy, while differentiating 1 by p, we have minus 1 by p square dp by dy, and then into y log y, and then plus. Now 1 by p is taken outside the bracket. Now we are going to differentiate y log y. While differentiating y log y, we have here as 1 by p log y plus 1. Okay, and then plus y plus, because we have 1 by y, so while differentiating y we have minus 1 by y square, and the minus and minus getting plus, so we have written here the plus sign, plus p by y square. And then we have a chance of differentiation of p, so minus 1 by y is taken outside, and we are now going to differentiate p. So while differentiating p we get dp by dy. Okay, now we just place all these terms. So we getting here as 1 by p equals to minus 1 by p square y log y into dp by dy plus log y divided by p plus 1 by p plus p by y square minus 1 by y dp by dy. Now here 1 by p and 1 by p is getting cancelled. So what we are left with, the term is minus 1 by p square y log y dp by dy plus log y by p plus p by y square and minus 1 by y dp by d, like this. Okay, fine. So now minus p by y square is taken in the left hand side, while the minus log y divided by p also, and the rest part, which the term containing dp by dy, is taken in the right hand side. So we have here is equal to minus y log y divided by p square minus 1 by y dp by dy. Okay, so this imply minus, then bracket p square plus y square, then log y divided by p y square, taking the y square piece as a LCM. In the right hand side we have equal to minus. Now p square y is taken the LCM, so we have here is y square log y plus p square. Minus is taken the outside. So both the left hand and right hand side we have the minus sign. So minus sign is giving the plus sign, and this imply 1 by y. Since we have here is p square y square log y, p square y square log y, both sides the same term, so we are getting cancelled this whole terms. So we are having here p 1 by py square equal to 1 by p square y into dp by dy. So now p and y again getting cancelled, and p and then y again getting cancelled. So we are living with the value 1 by y in the left hand side, while in the right hand side we are having only 1 by p into dp by dy. Okay, so this implies dy by y equal to dp by b. We just arrange the terms according to our integration. So integrating both sides, we have log y equals to log p plus k, and this implies y equals to pk, and this implies p equals to y by k. Since the elimination of p is possible here, that's why we are writing here p equals to y by k. Put it equation number 3. Now eliminating p between 2 and 3. Now what we do is we just put the value of p in the term which is the solver for x or solver for whatever we get the term. So here is equation number 2. We have arranged the term as for the solver for x. That's why we will put the value of p in equation number 2, and we will write like this: x equals to yk divided by y into log y minus y divided by yk. Okay, and this implies x equals to k log y. Y and y getting cancelled from the first term, so we are having here k log y minus y again getting cancelled, so we have here minus 1 by k. So we get the final result as x equals to k log y minus 1 by k. I hope you all like my video. Thank you all.